In western New York, being measured in feet, not inches.
One of the strongest storms ever recorded.
A relentless snowstorm.
Record rainfall.
Record-breaking rainfall.
With a new UK record temperature.
Earth is increasingly experiencing extreme weather, wreaking havoc across the world, devastating ecosystems, economies, and communities. When catastrophic weather strikes, it's often blamed on climate change.
Every few years, a powerful shift begins in the Pacific Ocean, one that changes weather patterns across the entire planet. This phenomenon is known as El Niño. Regions that are normally dry may face harsh storms and flooding. Areas that depend on rains can have a severe drought. Heat waves are intensified during this time, wildfire risks rise, and entire marine ecosystems are pushed to their limits as the ocean temperatures rise.
Normally in the Pacific, strong trade winds push warm water toward the western Pacific near Indonesia. Along the coast of South America, cold nutrient-rich waters rises to the surface through upwelling, which supports high biological productivity. But during an El Niño event, this entire pattern shifts. The trade winds weaken and sometimes even reverse. Because of that, warm water moves back toward the central and eastern Pacific and stays there. The surface currents slow down and upwelling drops, with less cold water rising to the surface. Nutrients stay trapped deeper in the ocean, and the eastern Pacific becomes much warmer than usual.
During a strong El Niño, sea surface temperatures in the central and eastern Pacific can be 2 to 4 degrees Celsius warmer than usual. These changes are tied to interactions between the ocean and the atmosphere, so when the winds weaken, the currents and the temperature of the water all change. For example, during the 2015 to 2016 El Niño, water temperatures peaked around December 2015 and spread across thousands of miles of ocean. Satellite data for events like this show strong sea surface temperatures behaviors with warmer than normal water stretching across the eastern Pacific. Depth profiles also show the thermocline sinking deeper, which makes it harder for nutrients to reach the surface. Chlorophyll levels drop too, because phytoplankton need cold, nutrient-rich water to grow.
El Niño is part of a bigger climate cycle called ENSO, which has 3 phases: El Niño, La Niña, and neutral. This cycle happens every few years, and each event is unique in strength and duration. Even though El Niño repeats over time, the impacts vary and can change global weather patterns.
Once these physical changes happen, they create a cascade through the marine ecosystem. Everything starts with the shift in temperature and the drop in upwelling. That causes a chemical change, otherwise known as nutrients. Once these physical changes occur, they create a cascade through the marine ecosystem. Everything starts with the shift in temperature and the drop in upwelling. That causes a chemical change, otherwise known as the nutrients decreasing at the surface. This disrupts the biological process of the ecosystems. The first group to respond is the primary producers. Because nutrients are dropping, the phytoplankton levels are also. The primary producers drop because they rely on those phytoplankton for food. After that, the secondary consumers decline or move away. Finally, apex predators such as seabirds, marine mammals, and large fish are affected. Many seabirds abandon nests or search farther for food, and sea lions and other marine mammals may show signs of starvation. Big fish like tuna and sharks move toward cooler water, where food is more reliable and less scarce.
There are clear winners and losers during El Niño. Warm water species sometimes expand into new areas because the water becomes more suitable for them. But cold water species like anchovies and sardines usually decline. The reason is because when the bottom of the food chain collapses, everything above it struggles. These changes always follow the same order. Winds weaken, upwelling slows, warm water spreads, nutrients drop, phytoplankton drop, zooplankton drop, fish numbers drop, and predators struggle. Recovery can take months or even years depending on how severe the El Niño was.
Scientists use different kinds of data to measure these changes. They create temperature anomaly maps that show you how much warmer the ocean has become. They use chlorophyll graphs to track productivity. They measure shifts in current speed or wind patterns. They also track chemicals such as nitrate levels to see how the nutrient supply changes. All of this data comes from the buoys, satellites, and government agencies like NOAA. Most of this research behind El Niño is peer-reviewed, and strong scientific sources are used to confirm the changes.
El Niño connects directly to major oceanic behaviors. It is one of the main impacts of ENSO. It affects global warming patterns because the Pacific releases huge amounts of heat into the atmosphere. It also slows down upwelling along the coast of South America, which is one of the most important upwelling areas in the world. Even though El Niño doesn't cause eutrophication, it does affect productivity by changing nutrient levels. All of these processes are important parts of ocean science.
Scientists are also studying how climate change might affect El Niño. There is growing evidence that extreme El Niño events could become more common as the planet warms, because warmer oceans store more heat and can create stronger anomalies. If these strong events happen more often, marine ecosystem and coastal communities will face bigger challenges. El Niño doesn't only affect the ocean, it affects people too. Fishing industries suffer when fish populations drop or move away. Tourism changes when wildlife is displaced or storms shift. Shipping routes may also be adjusted because of altered storm patterns. Some communities that rely on fish for food or income may struggle during El Niño years. Governments respond by closing fisheries, monitoring ocean conditions, and sharing early warnings.